And we are live. What is up, everyone? And welcome back to the HackSmarter Twitch channel, or if you're watching this after the fact, welcome to my YouTube channel. Just going to turn down my desktop audio. And guys, you may notice, especially those of you watching on YouTube, I figured out how to get Twitch chat pulled up on my screen. So like, for those of you on YouTube, you don't have to feel so left out when it feels like I'm just talking to myself and I'm answering questions to myself. There are real people on the Twitch chat. So I have that here. Have it pulled up. Hopefully everything looks good. This is the first time I ever put it on the screen. So as we go, for those of you watching on Twitch, let me know if the chat is in the way of something that we are working on, just so I can adjust it and move it around accordingly. But so far it seems to be working. I do have it set out to time out after 30 seconds. So after a message has been there for 30 seconds, it does disappear just so it doesn't fill up entirely. But now when people ask me questions on Twitch and I am replying to them, those of you on YouTube can actually see a little bit of the conversation. All that being said, what we are going to do today is we are going to dive right back into the Attacking and Defending AWS pathway by TryHackMe. A special thank you to my friend and fellow streamer, Callie Max. He took the previous room on Lambda, and today we are going to work on a challenge room doing data exfiltration using Lambda. As usual, I have not worked through this yet. I am going through this live, so we are going to stumble through it together, and I guess we will see how we do. Let me go ahead and share my screen. I'm gonna get Twitch, or actually OBS, pulled up over here so I can monitor things over there better. And there we go. I'm looking over at the chat. It looks like, okay, I'm gonna move. I already told you guys I'm gonna have to adjust the chat. I can see that we're doing white text on a white background, so that of course is not gonna work. What if I move the chat like over here maybe? Then you guys can see it. Hopefully it doesn't take up too much of this. But we'll see. We'll see. I may have to continue to adjust the chat. Like I said before, this is the first time I put Twitch on here. So we'll see how it goes. Looking over at the chat before we dive into it, Super P Potato says, does TCM Academy have any boxes to test what they teach? So TCM Academy, unless I could be incorrect on this, but when you go through a course by TCM Academy, they usually use other resources. So there's some machines on Hack the Box. I also believe they've made some custom rooms on TryHackMe for privilege escalation, among other things. And when you go through a course by TCM, they're usually using Hack the Box or maybe a custom teaching room on TryHackMe to go through the material. TCM Academy does not yet host their own machines, but I do know, based on LinkedIn posts, they're working on it. They're working on setting up their own like TryHackMe, Hack the Box type virtual lab to teach hacking. If I'm incorrect in the chat, someone correct me. And of course, people on YouTube will see the correction now that I figured out the chat. But okay, let's go ahead and dive on into things. It has been a little bit since I started this, but I believe I have everything configured. I just showed my access keys. If you guys got that soon enough, you can have it. If not, it won't work anymore for those of you on YouTube. But oh well. So let's keep going. Super P Potato said, great thing. So I also need Hack the Box or TryHackMe subscription. For TCM security, it depends on the path. I think most of the machines they use, well, you know what, now that I'm thinking of their flagship course on ethical hacking, you would need a Hack the Box subscription, because I believe some of the machines you go through are retired machines, and that requires a VIP subscription to access the retired machines. All right. We're doing some Lord of the Rings, it would appear. The Uruks of Mordor have hired us to get access to a crypto wallet in the AWS account belonging to a rival gang of Uruk-hai. The gang has obtained some AWS read-only creds to the target account through means you don't want to ask about. They probably rip someone's fingers off. Unfortunately, the crypto wallet, I feel like a crypto bro, is an S3 bucket protected by a VPC endpoint policy. You cannot access it from anywhere except the VPC. For this challenge, the read-only credentials are the same ones provided by the TryHackMe environment, so continue to use them. You'll want to leverage your attack box for this exercise, and I do have the attack box pulled up. Afmello said, hello from Dirty Mike and the boys. Don't know who that is, but hello, good to have you here. And Eat Your Bugs says, hi from Brazil. You have a very unique username, Eat Your Bugs, but good to have you here as well. All right, I am ready. Let's get started. As I shared before, for those of you just joining, I have not worked through this room ahead of time, so I'm going through this fresh. I'm going to make silly mistakes. I'm going to miss stuff that's obvious, so chat, I need you guys to help me out. Holler at me when I miss something, or if you know a better way of doing something, please let me know. I am nothing close to an AWS expert. I do web app pen testing. I don't yet do AWS pen tests. Accessing the environment, complete. We already set that up. I did it before the stream started. Now let's go ahead and go into this. So from our mission brief, we know the wallet in question is located in S3. So let us list all the buckets. Well, let us list the buckets. AWS S3 LS, very simple command. You can see what we're doing here. I'm making an API call to AWS. S3 and LS, I already configured my credentials, so we don't have to do a name profile because the main profile here is the TryHackMe one. Okay, so we can probably assume we have Maher coins and Mordor picks. I'm guessing Maher coins is the wallet, and we could attempt to list what's in the wallet. So you can see, I'm just making sure we're doing it right. I do actually know these S3 commands. I've used them many times in CloudGoat. And actually, you know what I should do, guys? I should probably rep, right? We got Paku here. If you've never used Paku, you know what? Quick commercial. Let me show you guys Paku. And then we'll dive into things. Paku is developed by the greatest pen testing firm on the planet, aka Rhino Security Labs, and it is essentially a Metasploit for the cloud. So it's an open source AWS exploitation framework created and maintained by the one and only Rhino Security Labs, and it's pretty dang cool. If I get the opportunity to use it, I'll demonstrate it on here. Otherwise, I'll do a CloudGoat scenario sometime with Paku. I've been learning Paku a lot more in the real world. I was helping with an AWS assessment this past week and was using Paku on it, and Paku is something that we keep updated regularly. Matter of fact, we just added a new module to it, I think a week ago. Afmela said Paku is a fish in Brazil. I do. Do you guys get the name? I believe Paku is in the Amazon rainforest, maybe in some rivers, and right, it eats stuff. So Paku, I guess, eats your Amazon environment. Pretty sweet shirts. All right, there's my quick commercial for Paku. Even though I am not clocked and not being paid by Rhino, I do think Rhino is like seriously a cool pen testing firm. It is such an honor to be part of the team. But let's keep going. My commercial is over. Looks like we're going to try to list it. So you can see it's AWS S3 LS again, and then we just have to specify the bucket. So it's S3, and then we want to go ahead and grab the bucket right here. So we'll just copy it because I don't want to type that. It looks like my attack box is being a little bit slow, but that's okay. Shouldn't be too big of a deal. And there we have password.txt. If it worked, we could just take the password out. I'm sure it wouldn't work. It says it looks like there's a bucket of scenic pictures of Mordor and a bucket with the head orcs coins. This should be easy. We have read-only credentials, and they allow us to do S3 get object. Right. Probably not. And you can see we'll do it even though we know it's going to error out. We'll do AWS S3 CP means copy, and then we want to specify that S3 bucket from before, so we will copy that again. And then it says, hey, where do you want to paste this? And we'll just say paste it in the current directory. Oh. I didn't get an error. Oh, I need to do password.txt. Let's do this. Password.txt. There we go. All right. Fatal error occurred. It is forbidden. We cannot grab password.txt. So why is this happening? Well, let's look at the bucket policy. So let's go ahead and look at that together and see if we can understand what's going on. I know we could just copy this, but I think it's important to type it out to build that muscle memory. So it's AWS, and we'll say, hey, we want to do the S3 API, get bucket policy, and then we want to pass it the bucket name, which is, of course, the Maher coins, but without the S3 at the beginning. So let's copy this. And then query policy, and we want it to output as text, and then we want to pretty form it with JSON with JQ, and let's see if that does it. Okay, it does. So here is the bucket policy. We have the SID, which is statement 1, kind of like a description, and the effect is deny. And who does this apply to? Well, it's a wildcard, which means this applies to everyone, which you're everyone, I am everyone. It applies to all of us. And what can't they do? Well, what's the not action? Well, that's interesting. The not action is put object. So you cannot put an object in this bucket. And what resource does it apply to? Well, it applies to this resource right here, which is our S3 bucket. But we have this string not equals the source VPC. So in other words, if the source VPC is this, so if we can compromise this VPC, this statement, this policy does not apply to us. So then I'd assume if we can compromise the VPC, we would be able to read the bucket. That's how I'm reading that. Too much talking already. I feel like every time I start talking on stream, I get stuffy, like I get a cold. All right, let's keep going. Let me ask you guys on Twitch, how's the chat been working? I haven't been paying attention to the chat overlay. Is it distracting? Is it in the way? Or is it okay where it's at? Let me know. Because people on YouTube aren't going to be able to tell me live. There is an explicit deny on all object operations except put object from everywhere except a VPC. All access to the bucket is restricted to the specific VPC endpoint. That is annoying. These next two commands will describe the network topology. The first command will list all the VPC endpoints, which she discussed in task 5 of the room, the one where I was very confused if I remember right. This will allow you to confirm which VPC is bound to the bucket policy we enumerated above. I think we see it's right there, but I suppose we'll check. AWS EC2 describe VPC endpoints. Oh, I did VPN. Maybe I should learn how to type. Okay, so we have our VPC endpoints right here. Here's our endpoint ID. Our endpoint type, our ID. Okay, VPC endpoint ID and VPC ID are apparently two different things. Our service name, the state, whether or not it's available or not, which it is. We have our policy right there. Allow access to any resources, so I think that's the VPC in question. If we scroll up to up here, does it match that VPC? So 04 is that VPC. And 04, it does match it. I'm going to grab this information right here because I'm guessing it's going to come in handy later. So we'll just go ahead and copy that and we'll open up Sublime Text. Paste that in. I'm guessing it will come in handy. So it wants us to describe VPC endpoints and then describe VPCs. What the heck is the difference? You know, this is where AWS is confusing. I guess it's giving us different information, but like that's totally not logical the way this is set up. But oh well, EC2 describe VPCs. So gosh, I can't type. I'm going to blame the attack box even though it's actually my fault. But just so I feel better about myself, I'm blaming the attack box for my typing issues. I don't like the attack box keyboard, obviously. So the describe VPC gives us the CIDR block, the DHC options, the VPC ID here, the owner ID, the association ID, CIDR block again, which matches what's up there. The state, which means associated with what? We have our stack ID, our Lambda capstone, and then Maher's VPC do not use. So we know that it belongs to him. I don't know what of this information we're going to need, but I'm guessing it will come back up. So I'm going to copy all of that. Can we get this pulled back up? There we go. You guys see it's a laggy. I don't know why. That's the downside, right, of having to use, gosh, when you have to use the attack box just because you're going through the cloud, so you're bringing in latency into it. It's not my own VM, which is what I prefer, but I'm guessing we're going to need a public IP for this challenge, which is why they're having us use the attack box. All right. We see a specific VPC with the name matching our target, Maher's VPC do not use. If we want to access the wallet in that bucket, we will need to be in that VPC. So I'm glad I correctly read the policy of the S3 bucket. So I'm going to count that up as a win. I'm going to take my wins. The unfortunate orc who provided our employer these credentials indicated that the account only has a few Lambda running in it. So in our next task, we will investigate those. We're going to begin to enumerate some Lambda functions. What is the not action value in the policy for the coins bucket? It's put object, right? You guys remember that? I don't actually think I put that in here. I believe it was put object maybe? No, maybe not. Off memory. Beautiful. What is the name of the VPC that we need to target? Now, I do think I recorded that information. Come on. There we go. The name of the VPC that we need to target. Is it the secret VPC? Maher's VPC do not use. Yeah, I bet that's the name right there. There we go. Beautiful. Reconnaissance of the Lambda in the environment. We will start with the simple list of the functions. So we'll do that. AWS Lambda list functions. Remember, these are serverless functions. And so let's read these functions ourselves before we read it from TryHackMe. Our first function name that we have here is a list images. And we have the function ARM, which is like the unique name. The runtime is Python 3.9, so it's running Python. And remember, Lambda functions can run Python, Ruby, and I believe a few other programming languages. And we have a description. It lists all the files from the Mordor Travel Agency. We have some environmental variables. Our log level is info, and it applies to the Mordor Pix image bucket. So probably not something we want. We don't want to see the images of Mordor. It's a pretty dark and fiery place anyways. Trying to scroll. There we go. All right, and now we have another function name right here, download images. And it applies to this, or it's this role. Oh, hold up. That role is Mordor Travel read image bucket. I noticed that this role, it's assuming in some way this VPC Lambda Amazon S3 full access, which sounds like it might be interesting to us. It sounds like it's an overly privileged role that it can do more than just retrieve images. I'd assume that would be able to also get this password for this, Crypto Bros wallet. Here's the description. Reads images. It's still Python 3.9. Security group IDs are VPC ID. Does that VPC ID match up with the VPC that we're targeting? The 0F. 0F right there. It does, okay. So if we can compromise that Lambda function, we have an in on that VPC, if I'm reading this correctly. And it seems to be overly privileged based on the role that is being passed. And then we have another function, THM budget Lambda function. Lambda function to be called after a critical budget threshold has been exceeded. Okay. Well, I think that's an actual like THM one. I don't think that's anything to do with the scenario. That's like if we start creating crazy EC2s in the TryHackMe environment, it lets TryHackMe know like, hey, Tyler is costing you a bunch of money. You should probably kick him off of the AWS environment. All right. Note that there might be a third Lambda function named StackSetBudget. I was right. You can ignore that as it's not part of the scenario. So what can we infer from the above? There is a serverless application that uses Lambda to serve pictures. We got that. One function lists the contents of the bucket and the other downloads the contents. We can see from the VPC config and the download images function that the function runs in the VPC required to access that bucket. And so we need to leverage that function to accomplish our objective. Guys, I'm going to count this as a win. I basically said that when I was looking at the policy myself. So I'm slowly learning how these things work together. And I would encourage you to do that same practice, even when you're not, live streaming, when you're just going through a room yourself and you're looking at something like an AWS policy, before you see what TryHackMe says about it, do it yourself. And I know it feels a little bit silly, but sometimes it's helpful to talk out loud. Maybe don't do it if you're at a coffee shop because you'll look weird. But if you're at home, say what you see out loud because it forces you to process and think as you do it. All right, what can these functions do? Run the following from your attack box to get the policies attached to each function. Are these the actual functions? We don't have to fill those in. I think those are actually called list images, right? Yep, download image. So those are actually names of the functions. And I noticed this with the AWS. When it does it, it actually breaks the terminal, so you have to reset the terminal. So let's read what this is doing. So functions, we're setting a variable called functions, and we're passing it to the two functions we discovered, list images and download images. And now we're doing a for loop, so it says for f. Now, if you know scripting, f can really be anything. You can put x there, d, the variable doesn't matter. But what it's saying is, hey, we want you to go through each one of these. So for f and functions means for each one of these. So first with list images, do all this, and then with download images, do all this. So what do we want it to do? Well, we want it to do this. We wanted to set a role variable. And here's the role variable. Here's how we want you to get it. We want you to do the command AWS Lambda get function, function name, pass it the function. So first list images, and then it'll do download images. But function name, list images, do a query. And we want you to query for the configuration role. We want to output it as text. And then we are cutting some things out to just to printify it looks like, to print out the information that we need. And then echo, the function, has that role, this role right here that we're making it a little bit more pretty with these managed policies. AWS IAM list attached role policies, role name, we're going to pass it the role, which is going to be from here after you run awk on it. For p in that, so now we're doing another for loop. So for each one of those policies, in that role, we want you to query the policy names and output the text. When you do that, we want you to echo this role, right? So this role that we're setting up here for F, so it's going to be like this role for list images has the inline policy of P. So that's what that P is doing, is getting the inline policies of each one of those roles, and it's going to print it out for us to do some enumeration. And then finally, AWS IAM get role policy for the role name role, and then for the policy name, which is going to be the inline policy, and it's going to spit that information out to us as well. So it looks like what this is doing is some basic enumeration on these Lambda functions. You could honestly turn this into a tool where it receives like the parameters saying, hey, pass it the functions you want to enumerate, and you'd be able to make a small little tool that does this for you as well. That's how I understand this code. Let's see if I'm right. The above command will iterate the list of functions, and for each extract the function's execution role and the variable role. And then list the attached policies for the role and any inline policies for the role. But we'll use that information in the next step as we analyze how compromising these functions can get us closer to our objective of reading the bucket. All right. Oh, I didn't copy functions. Okay. I was like, it's broken. There we go. All right, once again, before we look at TryHackMe, let's see if we can understand what's going on here. Can I move this over here? Yeah, there we go. List images has Mordor travel read image bucket with these managed policies, right? AWS full access, that's what stands out to me. Mordor travel read image bucket for list images has inline policy read image bucket. And our action is S3 list, so we can list anything in the S3 bucket. It applies to the Mordor picks. The effect is allow. Action logs, resource, everything, effect allow. Download images has with these managed policies. So here's the policy. It's a service role, VPC access execution role. We have this policy name, basic execution role, and then S3 full access. So we're going to somehow exploit these. Which Lambda function has the AWS Lambda full access managed policy attached to it? Well, the full access managed policy was up here, which is the list images role, or list images function, I should say. Which Lambda function has the IAM permissions to access any S3 object and any S3 bucket in this account? Any S3 object and any S3 bucket in this account. Well, I suppose read image bucket, right? Or maybe download images. Full access. Yeah, download images. Download images has S3 full access with these managed policies. So that would have access to everything, I would think. Overly privileged function. Download and analyze the Lambda functions. The function list images has the AWS Lambda full access managed policy. So if we scroll up, we can see that list images right here. Full access. This means it can change any other function. The download images function is already in the VPC, and it has the Amazon S3 full access managed policy, which would allow that function to view all of S3. It seems like a reasonable plan of attack is to use the credentials from the list images function to modify the code of the download images function. Got it. Let's get the code bundles for both of these functions with the AWS Lambda get function command. You should run this from your attack box. All right. So what are we doing here? We're passing our same functions, and we're saying, hey, for F, so iterate through this. Here's what we want you to do. Get function, function name, and it's going to pass it each function. We want to query the code location, output it as text. And then, oh, we're setting a URL parameter. I see. So we're just getting the URLs of the Lambda functions. And then we're going to curl those URLs, and we're going to save it as .zip. And if you remember when Callie Max went through the Lambda room, he demonstrated how you download that and analyze it. And I believe to get the secret flag there, you had to overwrite some Python stuff there, but you had to get the .zip file. And then we're going to make a directory. So we're going to curl it. We're going to make a directory that goes by that name, and then we're going to unzip it in the directory. Makes sense. Okay, we got download images and list images. I see both of those folders. The above command will loop that. We already kind of talked about that. Now that we have the Python code for both functions, let's look at how we can exploit them. Okay, let's look at it ourselves before I even look at the TryHackMe. So if I do subl, okay. Can I zoom in on this for you guys? There we go. Well, let's turn on word wrap. And I'll zoom in so you guys can hopefully see it a little bit better. So let's go through this step by step. We're importing Bodo 3. Now Bodo 3 is the software SDK. That's what I'm looking for. Software development kit for AWS. So you can use Python to interact with it. And then from Bodo core exceptions, we're importing client error. We're importing JSON, importing OS for commands, import logging, and importing date time. Easy enough. We're setting a logger variable, and then we're passing it this get logger function, and then logger set level. So here we're just setting the logging level, I suppose, for it, and we're passing it OS, get environment, log level, default info. So we're setting the log level to info, it would appear. And then we're doing get logger Bodo core, warning, define Lambda handler, event context. So this is just setting some logging information from what I can see. Ugluk gave me this command to run. Okay, so this is the command. What is the command? Well, we're doing a command, and then we're passing this F string, AWS S3 ls S3, and you can remember this was a command used to list all the content in an S3 bucket. All right, and then we're getting it, stretch, from the operating system environment, and we're getting the image bucket here. Event, prefix, files, variable, OS, open, command, read. So it's just reading. It's reading everything in the bucket from what I can see, and then returning the files. That's how I understand that. And we can see this. The first function we need to attack is the list images function. If we look at the code, you see there's a very simple Lambda that runs the AWS CLI and doesn't sanitize any inputs. This should be easy. So it's just sharing it with us here. When passed the following JSON, this function will return a list of objects in the image bucket, then run whatever else we need to, then run whatever else we add to the end of the command, something like this. Okay, got it. If we look at the download images function, so let's go ahead and look at that now. And we'll go ahead and turn on word wrap. So very similar thing here. We're just setting up logging, it looks like, and we are setting up a client or almost like a session, S3 there, and we have a try and accept statement. So what are we trying? Well, we want to get a response variable from the S3 client. So we're passing it from the Boto3 SDK. We want to get the object, and what object do we want to get? Well, we want to get the bucket, image bucket, and then pass it the key, the object key. And then for the contents, I think my word wrap is kind of screwing up the spacing. Contents equal string, so it's a string, and we want to get the response of the body. We want to read and then decode it with UTF-8, so it's readable for us. And then we're passing it to the logging, and we're saying, hey, the file contents are the contents after we decode it. So it's going to show up in the log, it would appear, except, so here's where they try and except if there's a client error, then we say, hey, client error getting this S3 bucket, blah. Otherwise, return contents. If we look at the download images function, we see this function's author used the Python library for AWS, Boto3. As a result, we cannot simply invoke this function to access a password.txt file in our target bucket. But when we invoke the list images function and get those function credentials, we will have the power needed to modify the download images function. So let's make a few changes to the index.py in the download images function. Okay, so it says change line 18 from bucket OS environment, we want and get the image bucket, and we're updating it to just set the bucket to the coin. So we're, instead of targeting the image bucket, we're going to target the crypto wallet bucket is what we are changing there. So we need to go ahead and grab that information. I thought I had 2 of this open. Gosh. Where are my notes? There we go. Can it open? Just being slow. Do I not have the bucket information saved here? No, I'm dumb. Why would I not save that? Did I not think I would need that bucket? All right, well, let's get it real quick. So it was what? AWS S3 LS. There we go. I'll just grab both of these. So we will copy that. Go back to Subble. Go to, I believe this one is my notes. And we'll just drop this at the top. And let's go and grab more to our coins here. Copy. Wish I could Alt-Tab, but that doesn't work when you're using the attack box. And now we want to pass it the bucket. So I'm just going to change this. Come on. There we go. That looks good to me. And replacing that with the correct suffix, the function already returns the data and logs the file's contents to CloudWatch, which is line 22. That's what I was talking about with the logging going on. So we don't need to do anything else. Save the index.py file and create a new zip file with this command run from inside the download images directory. So let's go ahead and save that. And if we go back to our terminal, come on, I believe in you. There we go. So save the index.py file and create a new zip file with this command. So cd download. All right, let me just make sure that did change. Yep, we can see the bucket name being changed there. And essentially we're just going to re-zip up that full folder. And we're calling it compromise.zip. So we'll do zip -r. We want to save it one directory out. Compromise.zip. And then we want to zip up the index.py that we just modified. Now we should see compromise.zip. Yep, I do. will we use compromise.zip later in task 6? Who gave the list images functions author the vulnerable CLI command to run? Well, that would be this guy. Come on. I can't type that on my keyboard, at least I don't know how. He's a really ugly looking dude if I remember right. There he is. Look at that guy. Isn't he pretty? He'll be the next Twitch streamer. Very nice looking gentleman right there. Apparently isn't that good at writing code either. Vulnerable code. Exfiltrate the credentials. All right. We are now ready to commence our attack. Create a file called payload.json with the following contents. And so you can see we're just passing it the prefix that for the environment, since it's not sanitizing the input at all. That file will tell the function to run the Unix command environment, which will print out all the environment variables used by the function. We will invoke that function with the following command. We pass in the JSON payload and have the output written to the file output.json. We'll then parse the output.json looking for the environmental variables that begin with AWS. Let's type this full thing out. AWS, Lambda, invoke, and then, invoke, we want to pass it the function name that we're invoking, which is the list images function. And then we want to give it the payload. So we're saying, hey, we want you to do this file. Okay, I guess I got to type it. And then save it to output.json. Let's see if that works. Fingers crossed. So now we want to cat that, and we'll do JQ for JSON to pretty it up, and we want to grep for AWS. Okay. We have what appears to be a session token right there. And we have an access key. We have a default region. Oh, we have a secret and an access key. So now we can set up a new name profile, and then we have the permissions that are running as this Lambda function. So that's actually pretty dang cool. We printed out the environmental variables to grab those credentials. That's neat. Now open a new window in your attack box and set the environment to use the new credentials you've just exfiltrated. You'll want to use a new window since you'll be operating as a different IAM identity. Make sure to use this window for all the commands going forward. We could also set it up a different way. You guys are going to see my AWS credits or TryHackMe, but what's my name? Am I running as Ubuntu? No. Oh, I'm running as root. Maybe if I would just like look at the freaking terminal instead of being a noob, I would know that, huh? Is there no AWS? Well, I'd assume there would be. Usually that's where your credentials are stored at. Oh, well, I guess I'll do it their way. So let's go and open a new terminal. And we want to go ahead and do export AWS. And we need to get our session token from up here. It's kind of like a JWT is how I think of it. Copy. I hate switching terminals on the attack box. Because I have another screen over here, often it jumps to my other screen instead of to the right terminal. See what I mean, guys? What the frick? It's definitely not what I opened. Okay. And what's the next one? We'll do the secret access key. So you can copy the full thing and we'll just export it that way. Dang it, Zeus said, what does AWS hacking mean? We are learning how to exploit AWS environments. AWS is Amazon Web Services. It's what many websites run on. And we're looking at how to exploit misconfigurations in the way AWS is set up. I don't know your name. Rocha said, is it possible to open a terminal tab instead of a window? We actually have to do a new window because we're setting different environmental variables. I think a tab would keep our previous environmental variables, but I could be wrong. But I think that's why you're supposed to do a window. I could totally be wrong, though. People who are smarter than me can correct me on that. Okay. And then he said, dang it, Zeus said, so is this post-exploitive activity like we're already inside an AWS environment? You got it. So we began with read-only credentials. We exploited a Lambda function to print the environmental variables because the Lambda function was not coded properly. And so we got a second set of credentials that gives us access to override another Lambda function that we're going to use to pull down a crypto wallet, essentially. There we go. So it looks like it worked. You can see that's kind of like the who am I for AWS, that command right there. And hey, the attack box has started working better for me. That's strange. It's smooth now, not so laggy. But that's like the who am I for AWS. And you can see we assumed this role of listing images, which gives us permissions, I think, to overwrite the other Lambda function. So I think we'll be able to modify the other Lambda function now. Congratulations, we have now escalated our permissions. What is the value of the AWS execution environment environmental variable? Right here is the answer. So we'll go ahead and copy that. Boom. Compromise VPC enabled function. Now that we're operating with escalated permissions, update the downloaded images function with the zip file we created in task 4. And remember, we did create that previously, but we have to do that from our other window. There we go. Where the heck did I save that? Yo, where are all of our files at? Am I blind? Just in our home directory. Okay. There we go. So if we go to compromise, right? Compromise.zip, that's what I'm looking for. That's where we put that if I remember right. Dang it, Zeus said, how do you protect a Lambda function against this type of privesc? Well, I think there's multiple issues going on here. One issue is the Lambda function is overly permissive. It has more permissions than it needs. So we always need to keep in mind the principle of least privilege. It should apply to functions as well as to people. Only have the privileges you need to perform your job duty. The other part of it is the code. So Lambda functions can be written in different code. This one was written in Python, and it was passing it user input that was not sanitized correctly. And because of that, we could abuse the code of the Lambda function itself to essentially escape and then print the environmental variables. And the environmental variables are what store the credential. So we abused the badly written Lambda code that wasn't sanitizing user input and then used that to pull down the variables. So there's a few wrong things going on here that allowed us to compromise it. Hopefully that makes sense. Perry Letts, what up? Hey, good to have you here. Okay, let's update the downloaded images function with the zip file we created in task 4. Let's do it. I'm going to type it all out once again for muscle memory. So AWS Lambda update function code. Unlike many things in AWS, that command actually makes sense. Region is US East 1 because that's a region it's in. And then it says, hey, what Lambda function do we want to update? Well, we want to update the download images function. And what do we want to pass it? Remember, Lambdas accept zip files, writing code and saving it as a zip. So we compromised it and we saved our new index.py in that compromise.zip file. So it says, hey, let's go ahead and pass it this file, compromise.zip, and let's see if it works. Okay, it did work. And now my terminal broke because it always does with AWS for some reason. And it says create a new file, payload.to.json with these contents. Recall from task 2 that password.txt is our target. So I'll just show you guys that S3 LS. Oh, I'd actually have to do that from the other one, just so we can remember kind of our target here. So if we list our S3 buckets, we have the coins, AWS S3 LS, and then we can pass it this. And you can see we have password.txt, and if we try to copy that, to our current directory, we get access denied. It's forbidden. So that's what we want to get a hold of, is that password.txt, and that is why we are targeting it. So we'll do nano payload 2.json. We'll copy in that JSON, which is just the object key of password.txt. Beautiful. And now we want to invoke the compromise function to read the target. And hey, what is up, the ball caker with the raid party of 6? Good to have you guys here. We are hacking some AWS Lambda functions right now. So welcome to the party. All right, invoke the compromise function. So let's go to invoke the compromise function, AWS Lambda invoke. We want to pass it the function name, and the one that we compromise is download images. And it says, hey, what payload do we want to pass it? Well, we want to pass it the payload.to.json, and let's save the output to output2.json. Let's do that. Beautiful. Do you know how the orc first came to be? They were elves once taken by the dark powers, tortured and mutilated, a ruined and terrible form of life. And that's apparently the password. I love it. So copy, paste. Okay, so the password that we couldn't get previously, right here, right? We cannot get this password. Remember what we did. If we retrace our steps, we wanted to get access to the Scripto wallet. We found 2 AWS Lambdas. The first one was not sanitizing user input correctly. We abused that to read the environmental variables to pull down a second set of AWS creds that were overly privileged. They did not follow the principle of least privilege. We used those overly privileged AWS creds in order to modify the second Lambda function of download images, because it had full access to the S3 bucket, and we changed the bucket target. Remember, download images was only set to Mordor images. We changed it to target Mahar coin, so we changed the bucket there in the code, and then once we had this new role with new permissions, we uploaded our new code, we ran the Lambda function, and we pulled down password.txt. So what did the orcs of Mordor do wrong? Let's see if I was right. You guys asked this. We'll see how close I was to describing the issue here. Our orc friends made several mistakes in their cloud security. Number 1, overly permissive roles. Called that out. Good job, Tyler. I'll take this as a win. The download images function didn't need Amazon S3 full access. The purpose of that function was to access a specific bucket. If they had scoped the policy to the right bucket, you wouldn't have been able to access the coins. Secondly, the list images function didn't need AWS Lambda full access. That managed policies for account admins to create and manage Lambda, not for the Lambda functions themselves. And you'd be surprised how often we see this in the real world. I shared before, I don't do AWS pen testing yet, but I do QA it. So when another pen tester at Rhino does an AWS pen test, we have people QA it before it goes to the client. So I've read through many AWS pen test reports, and this is one privilege escalation path that we see is overly permissive roles. It's huge, and many companies have this exact issue. Unsanitized inputs. The list images function didn't validate the event prefix before passing it to the shell. Thus, we were able to use a simple command injection to access the environmental variables in AWS creds. I also called that out. I'm 2 for 2. Lambda in a VPC, I did not call this one out. There is no good reason to place the download images function and the Maher's VPC do not use VPC, right? Maher, or whatever his name is, going to be mad because they used it. Sometimes developers and security architects have on-prem thinking and believe a Lambda function in a VPC is more secure. As Lambda functions are invoked and managed via IAM permissions, granting them unneeded access to the private corporate network allows an attacker to laterally move from the cloud to the network. 4. Leaking read-only credentials. We don't know how your employer got the read-only credentials to Maher's account. However, remember it said we didn't want to ask. They probably ripped someone's fingers off. However, with them, you could quickly find the bucket that you wanted, the object in the bucket, the network layout, and download all the Lambda code in the account to inspect them for vulnerabilities. Read-only access is a very powerful managed policy and should not be used lightly. Matter of fact, when we are doing an AWS pen test, we often ask for a role that has read-only access to the full AWS account just to speed up our process of enumeration and scanning and looking for what privilege escalation vectors are there. So when we do a pen test, we ask for read-only access. You don't want to give that to someone because they can really use that to enumerate your account. Account separation. The orgs use one account for everything. AWS recommends creating new AWS accounts for each different application and business function. The Mordor travel image application and Maher's crypto wallet should never have been co-located in the same AWS account. Which managed policy seems harmless but should not be used lightly? I think the answer is read-only access. Congratulations, you are my only friends. I'm sharing it with you live on the spot. We successfully completed the Lambda data exfiltration room here on TryHackMe. So thank you for hanging out. For those of you on Twitch, I will hang on with you. But for those watching on YouTube, this is going to be the end of the video. For those on YouTube, just jump to the next one and you can continue the series with me. I'll see you guys later.